and welcome to the following episode. So in this one we are going to create our own web server. So I think that's quite useful. Actually, it can be for the toolings to have like a endpoint where you can trigger an action. So um, this one is probably really important, and I'm quite again really um, honestly surprised that at the first chapter we go through this thing. So let's get started. I'm gonna open Visual Code in the folder chapter 1, go 1 tutorial. Okay, and it's called server1.go. Server1.go. Alright, there it is. So Go library make it easy to write a web server that responds to client requests like those made by Fetch. In this section, we will show a minimal server that returns the path component of the URL used to access the server. That is, if the request is for localhost 2.port 8000/hello, the response will be the URL path hello. Okay, so it's just to detect which kind of uh, path we're trying to access. So it's a program once again. So package main. We have a main function which is using the net HTTP library, handle func, and then handler. All right. And they say that each request calls the handler, log fatal http listen and serve localhost 8000 mail. So let's try to understand this. So handle func registers the handler function for the given pattern in the default servmux. The documentation for servmux explain how the patterns are matched. So in this one, we are just saying that actually the root path is a valid path, if I understand correctly, to the handle functions to the given pattern. And then say again, it takes a pattern string. So here the root path, and handler func, and the handler is a function with a response writer and a request. Okay, I'm confused. I don't really know what it does. Maybe I will understand a little bit later. So we are using log to display equivalent to print followed by a call exit. So if HTTP listen server has a problem, then we log fatal the error probably, because listen and server only return an error, as you can see here on the right top of this box and this small box. So yeah, it will log fatal F, it will log the error if there is one. And then listen and serve, listen on the TCP network address ADDR, and then call serve with handler to handle request on incoming connection. Accepted connection are configured to enable TCP keep alive. The handler is typically nil, in which case the default server mux is used. Alright, listen and serve always return a non-nil error. Good. So here we are just actually creating the server. So the code has the following function. I'm gonna put it here. Func handler. Handler is a HTTP response writer and a request. HTTP request. All right. Then we just print. No, something is wrong here. No. fmt fprintf. So we're gonna write on the this time not the standard output, but we're gonna write to W, which is our response writer. and then we will return URL path equal %q \n return line URL path. So that's what we're gonna return to the response. So that's the response we're gonna return when someone tries to get the root path or whatever is behind. Okay. So the program is only a handful of lines long because library functions do most of the work. So yeah, that's also why it's a bit confusing and I don't really understand what's going on behind it because it's mostly handled by the library. The main function connects a handler function to incoming URL whose path begins with / which is all URLs, and start a server listening for incoming requests on port 8000. A request is represented as a struct of type http.request, which contains a number of related fields, one of which is the URL of the incoming request. When a request arrives, it is given to the handler function, which extracts the path component /elo, for example, from the request URL and send it back to as a response using fmt fprintf. Web server will be explained in detail section, blah, blah, blah. Let's start the server. So let's start the server. Now, go one tutorial, then here, go run, how was the name? Server 1. Okay. So it's gonna probably ask me the permission. No, not even. So the server is now running. And I can probably curl localhost 8000 and it will return. So like, for example, here, when you write that, it's like writing http and just the path. So here it just returns the URL path, which is nothing. And if I write hello, URL path, hello. All right, so that's what the web server is doing right now. Not a lot, but as you can see, you can start a web server with just few lines, 2 lines, and one for the handling the response. So it's quite easy to create your own web server in Golang. So to make a HTTP endpoint that can trigger action, it actually seems really easy. So there was instead of using curl, there was using fetch that we made in the previous exercise. Go run fetch cd go tutorial, go run fetch go, and then http localhost hello. But as you know, it's like using curl, so well, it doesn't change anything. 200 okay, 200 okay, http localhost blah blah hello. That was the request, and then the answer is here. So everything is fine. It's easy to add features to the server. One useful addition is the specific URL that's return a status of some sort. For example, this version does the same echo, but also counts the number of requests a request to the URL /counts, return the count so far excluding /count requests themselves. So in the following code, I can copy it, I guess, because it's gonna be a little bit similar. So server 1, server 2, go. And now in this one, we're gonna just change something. Oh, they create 2 global variable, a mutex, and a count. So the mutex, I don't really know what it is. I think it's to lock the access of a variable because the web server is threaded. So if 2 people try to access the variable, it will not let the other thread access the memory and write it while the first one didn't finish. I think that's something like that. I would have to check. HTTP handle func, and they also add another one, which is handling the count. Handle func count. So this one will be using the counter. So we change the handler now. We're gonna use the mutex also. So mu.lock, it has sense from what I said just before. Then we increase the counter, and then when it increases, we unlock. So I think it's what I said. The mutex is to avoid to access the variable while we are doing something on it. And then we printf the URL path like we did before, but now we also have the function counter to create. Yes, counter, w http response rate as the same way, because we have to respond, and then also http request. Okay. So now our counter is gonna mulock also the access of the variables, because we're gonna access it and print fprintf. So here we're printing on W, and then we're gonna print the count %d because it's a decimal, and then count mu unlock, and that's it. I think it's that. The server has two handlers, so yeah, we have two handlers, and the request URL determines which one is called. A request for count invoke counter, and all other invoke handler. A handler pattern that ends with a / matched by any URL. Okay. To what they say. However, if two concurrent requests try to update count at the same time, it might not be incremented consistently. The program will have a serious bug called a race condition. To avoid this problem, we must ensure that a most one Go routine accesses the variable at a time, which is the purpose of the mu lock and mu unlock. Call that bracket each access of count. We'll look more closely at concurrency with shared variable in another chapter as a rich example. So then after it's another example. Let's try this one. Go run to fmt print. It was not fmt printf. Oh yeah, it's a mistake. Printf. Yeah. All right. So the server is running. Now let's say I want to check how much is the count. For the moment 0, but now if I try hello 2 times, and then I call count, then count is 2. Okay, so seems clear. We have two handler function, one for all the path possible, but one specific for count. Count is handled by the counter function, and those are ones by handler. The handler is doing the same thing, but we have the mulock to just lock the access of count, and the counter is also using mulock to avoid access the variable count while we print it. So that's it. Nothing more for this one. Then we also have a server 3, and in this one, it's another one. As a richer example, the handler function can report on the headers and form data that it's received, making the server useful for inspecting and debugging requests. Okay. We can change a little bit the handler function then. Let's try this one. cp server2.go server3.go. Let's see how they improve it. So, oh, it's more for debugging, okay. fmt, fprintf, and then w, then we send this, and we send what? We send r method, r url, r photo. Okay, let's remove this. It seems they don't use it anymore. For the moment, I'm just doing this way. For kv, so for key and value in the range of r header, we're gonna f printf w header wq equal wq. It's to print all the header of curl request or get request, HTTP request. Okay. fmt printf still w host unr host fmt printf w remote addr. I think you get it, but it's just to display everything we have inside the HTTP request. So remote addr, probably yes. Okay, and then if error parse form error is not equal to nil. So this is another way to write to declare a variable, call a function, and also check the return value at the same time, because parse form is only sending an error or nothing. Either it returns nil or error, so you can write this way. So if declaration or initialization declaration, then condition, and you do something. So here we insert inside error, we call rParseForm and we insert inside R the return value, and then right after that we check that error is not equal to nil. So we didn't see it before, so just explaining to make sure that you understand that's what's happening here. So range r.form, and we're gonna do the same. We're gonna display everything we have inside the R form. So w form wq equal wq percentage q, then kv. There it is. So the counter is useless, we don't use it anymore. So we don't use the mule and the count anymore, and we can remove also this function because we're gonna not use it. We're not going to use it. So here, let's try this. Let's try this. Go. It's running. Then curl hello, and then here they will print the. So you try to get hello with HTTP1. So that's what you can see here, just above it here. So we're printing the R method, the R URL, and the R proto. So the protocol used was HTTP.11, and it was a get, not a post. So for example, if I try a post, I'm not sure it's gonna work this way, but let's try it. Let's try this. Then yes, it works. So the method is a post on hello. Here is my header. Here is my other user agent header. Here is my accept header, and the host I've reached, and the remote address is mine, so it's localhost because I'm working remotely. I'm working locally. So here it is, and it looks like there is no parse form to show. Let's try. I'm not sure it works. But x d equal. Is it like that? No, like that. Equal value. Yep. So the form param with key param as the value. And that's it. And then after that, they try to implement the list ajout, so the animated GIF we did before. To be honest, I don't feel like showing this example because it doesn't give anything. It's really easy, and the list ajout was, in my opinion, really useless, and I don't want you to waste your time with that. So the only exercise they asked was to modify the Lissajous server to read parameter value from the URL. For example, you might arrange it so that URL like localhost blah blah blah, and then give a parameter cycle equal 20. Then it changes the variable of cycles. I think we can just avoid this. It's super boring, and I'm done with Lissajous. I don't want to do this again. So now for the chapter, there is only one more section, and I think I will keep that for the next video. And then we will be good for this chapter, and we will be ready to start to work on the program structure, which is a chapter 2. Thank you for watching. I hope you enjoyed. If you have any comments, feel free to put some comments above this video, under this video. And if you have any question or something you would like me to go more deeper, just ask. It's fine. Thank you very much. Have a nice day.